This is geometry level 2. A triangle has 3 angles and 3 sides, and it is a guaranteed fact that the 3 angles of a triangle add up to 180 degrees. To prove it, we're going to use something else that makes 180 degrees, which is a straight line. If I draw a parallel line to the vertex of one of the triangles, angles, if I draw it parallel to the opposite side, I will create some angles that have to be the same size as some other angles. Angles 1 and angle 4 are alternate interior angles, so they must be equal. And since these lines are parallel, we also have 2 more angles that are alternate interior angles, angles 3 and 5. So I can write that down, that angle 1 is the same size as angle 4, and also that angle 3 is the same size as angle 5. Since this yellow line makes 180 degrees altogether, I know that angles 4 plus angles 2 and 5 all team up to make 180 degrees. My goal is to prove that angle 1, 2, and 3 make 180 degrees. I don't have that. I have angle 4, 2, and 5. I'd want to change the angle 4 and 5 into 1 and 2, or 1 and 3. And I'm allowed to do that because of substitution. Angle 4 is the same as angle 1, so I can replace angle 4 with angle 1. And also angle 3 is the same as angle 5, so I can replace angle 5 with angle 3. And that is how you prove, through substitution, that the 3 angles in a triangle add up to 180 degrees. Let's talk about congruent triangles. The word congruent means exactly the same size and exactly the same shape. The symbol for congruent has 2 parts to it. The equal sign means the same size. The decoration on the top means the same shape. In these 2 triangles, they are the same size and the same shape. Because they are the same size, we know that AB must be equal to DE. We also know, because they're the same size, that BC is equal to EF. And because they're the same size, we know that AC, the length of AC, must be the same as the length of DF. Because they're the same shape, we know that angle A must be the same as angle D. Because they're the same shape, we know that angle E must be the same size as angle B. And because they're the same shape, we know that angle C must be the same size as angle F. So congruent triangles give us same size and same shape, 6 equal parts. In order to prove that 2 triangles are congruent, that they're the same shape and the same size, we don't need to actually find a single angle. As long as we know that there are 3 sides of one triangle that match up with 3 sides of another triangle, we'll have enough information. So as long as the triangles are the same size on all 3 sides, that's enough to prove that the 2 triangles are congruent. We got 3 matching sides matching up with 3 other sides that are equal, and that means that all the angles would also have matches as well, and that would prove that the 2 triangles are congruent. And the reason why would be called side, 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 or SSS. Another way to prove that 2 triangles are congruent is to find 2 sides that match up, 2 other sides that match up, and the angle in between agreeing with both triangles. So in this particular triangle, I got a side, an angle, and a side that I know of that are exactly equal to a side and an angle and another side. And that pattern of side, angle, side, where the angle is in between the two sides, is enough to prove that the two triangles are congruent. Notice where the angle is in this abbreviation, SAS. The A is in between, and in the picture, the A is in between the two sides. And because of that pattern, I can say that the two triangles are identical. Another way to prove that triangles are congruent is to find another pattern, is to find a pattern called angle, side, angle. If I knew that these two angles in yellow were exactly the same, and I knew that these angles in purple were exactly the same, and I knew how long it was from A to B, and it was the same length as it is from D to E, I would have something called an angle, side, angle pattern, which proves that the triangles would have to be congruent. As long as we have a side that's sandwiched in between two angles, we would have enough information to prove that the triangles are congruent. The important thing about angle, side, angle is to notice where the side is. The side is in between the two angles. So it sort of makes like a sandwich, with the side being the peanut butter and jelly and the two angles being the bread. And that matches up with the other angle, side, angle pattern in the other triangle. So I can say that these two triangles would have to be congruent. Another way to prove that triangles are congruent, a fourth way, is to look for an angle, angle, side pattern. Very similar to the one we just did, where there are two angles that are congruent and two other angles that are congruent. But the last piece would be a side that's not in between the two angles. Notice in the abbreviation called AAS, angle, angle, side, the S is not in between the two A's. And in the picture, it also shows up the same way. Here are our two angles, and the side we know is not the side that's in between the two angles, but the side is not in between, so it's not sandwiched between the two A's. And because of this angle, angle, side pattern, we could say that these two triangles would have to be congruent. All right, here is a slide where I'm going to actually use congruent triangles to prove a mathematical fact. In this question, I'm going to see if we can find a way to prove that the base angles of an isosceles triangle, to prove that they always must be the same measurement. To do that, what I'm going to do is I'm going to start with an isosceles triangle, and I'm going to take the vertex angle and draw in or construct an angle bisector of angle ABC. I can do that with a compass, like I've shown before in the level 1. So to gather my thoughts together on what I'm doing, I'm going to begin by creating a two-column proof. On the left-hand side, I'm going to write the facts, the things that are guaranteed to be true. And on the right-hand side, I'm going to write or list the reasons why they must be true. For this particular proof, I'm starting with an isosceles triangle. Triangle ABC is isosceles. And I'm also starting with an angle bisector that I constructed. And this angle bisector that I constructed was for angle ABC, the angle at the very top. These very first two reasons, the reason why they are true is because they are given facts. They were given to us in the picture to begin with. Now here's where the work comes in, is actually proving that these two triangles are congruent. So the very first thing I'm going to do is I'm going to talk about some parts that must be congruent. So to begin with, AB must be the same as CB. Why? Because the triangle is isosceles, and isosceles triangles have two equal sides. So that gives me a side matching up with a side just to start off with. The next move I'm going to use is based on that angle bisector. BD bisects angle ABC. So this large angle ABC gets split into two equal angles, these two angles there and there. So I would write down that angle ABD must be the same size as angle CBD. And the reason why I know that's true is because angle bisectors make two equal angles. So I'm sitting on a side matching with a side and an angle matching with an angle. I'll need one more piece in order to prove that the two triangles are the same size and shape. And to do that, I'm going to use the side right down the middle. So it is true that BD in the triangle on the left is the same size as BD in the right-hand triangle. Triangle on the right-hand side. We have a name for that. It's called the reflexive property. When two triangles share a side or an angle, we could say that it's true because of reflexive or reflexive property. That actually almost finishes my proof. The last thing that I'll need to do is shrink this down so we can fit it all in. Oh. All right, very good. We only have two more steps left to finish this proof off. This is the big step right here. We've proven that there's a side, an angle, and a side that match up with a side, an angle, and a side. So now I can say that triangle ABD, the triangle on the left, is exactly the same as the triangle on the right, CBD. The reason is the pattern side angle side. Now that I know that those two triangles are congruent, every part in one triangle must have a matching part in the other triangle. So in step 7 I can write down that angle A must be the same as angle C. And the reason for that is nicknamed CPCTC. The corresponding parts of the congruent triangles must be congruent. In other words, if the two triangles are exactly the same, every part in one triangle must have a matching equal part in the other triangle. You can see why it's nice to have an abbreviation for something like that, but it can also betray you too. So if you forget the reason, you could always write out a sentence instead, that every matching part of one congruent triangle must be congruent to another matching part in the other triangle. All right, continue on with these lessons and put it all together. I mean, this is a very important process that you're going through, is walking through these different levels of instruction. So hopefully this did pay off, and you want to keep up with looking at these videos to make sure you know the most important stuff.